Hello and welcome to my Cisco Packet Tracer introduction video. So what we're going to be doing today is using Cisco Packet Tracer. Cisco Packet Tracer is a cross-platform visual simulation tool designed by Cisco systems that allows users to create network topologies and imitate modern computer networks. It allows users to simulate the configuration of Cisco routers and switches using a simulated command line interface. It also makes use of a drag and drop user interface, allowing users to add and remove simulated network devices as they see fit. So this software is free to download. Okay, it's mainly focused towards CCNA students as an educational tool for them to learn those concepts. But now it's free to everybody. So what you're going to have to do with Cisco Packet Tracer before you use it, you're going to want to go to www.netacad.com and sign up for Cisco Networking Academy account. And that's free. You don't have to take any courses or anything. You just need the actual account to sign in to Cisco Packet Tracer. Some of you may have Cisco Packet Tracer installed on your computer, especially if you're at school. If you do not, you can download it for free, but all you need to do is, after you sign up for Cisco Networking Academy account, you have to enroll in the free Cisco Packet Tracer course, and then I think it's by lesson 2, they'll give you the downloads. You can just go ahead and download on it. You can use Packet Tracer on Linux and Microsoft Windows. There's also similar Android and iOS apps available, but you can create simulated network topologies. So if you're a visual learner or a hands-on learner, this will be very good for you trying to learn networking. You might look at this and be like, hey, look at this. I could probably learn networking just by using this. So what we're going to do is, after it's downloaded, or if you already have it on your computer, we're going to go to Cisco Packet Tracer. And it's going to pop up on my other monitor. Oh, no, it's good. Okay. So you can kind of see this is a little intimidating. You got a lot of shapes and icons, and if you click on these, you're like, oh my gosh, what are all these? We're just going to do a basic overview. In this tutorial, I'm going to show you how to make a basic private network, add some switches, or add a switch, add a router, add a server, how to use a server in a network, and just have a basic private LAN. Okay, so let's get started. So right here down the bottom, you've got all these icons, and these are stuff you can put into the actual work area here. You've got a logical and a physical view here, and the top here are our main buttons here. So we've got network devices, which will give us some options here: routers, switches, hubs, wireless devices, security, WAN emulation. End devices, you can give us some home, smart city, industrial, power grids, and then just generic end devices, components, boards, agitators, sensors, connections, structured cabling, miscellaneous, multi-user connections. So we're going to start with putting in an end device. So we're just going to use a generic PC. Okay, PC 0. Okay, and we're going to put a server on the network. Okay, so we just bought these two things. Okay, bam, we put them in a building. Okay, so I can put Solitaire on here, and the server just kind of sits here. We need to be able to have the PC to connect to the server. Okay, when you hover over PC, you'll see there is no Ethernet link, there is no Bluetooth link. All we have is the MAC addresses. There's no gateway, no DNS server, nothing set, so it can't connect to anything. Okay, same thing with the server. No fast Ethernet, no IP address, no gateway. Okay, so the trick is we need to link these two together. Okay, we do that by networking. So we're going to do our network device here. Okay, we've got some choices. We've got a router. Okay, we've got a switch, a hub, okay, and some wireless devices. Generally, you're going to want to use a switch. Hubs are unsecure. They broadcast all the information to everybody. They're slower. They're also on their way out. we're going to use a switch. So you got a couple choices here through all of these. You may look at this and be like, oh my gosh, I have no idea what I'm looking at. And that's okay. You can just research these if you wanted to. I will tell you there's two that you can pretty much just be emphasis that are emphasized. This one is 296024TT. It's a 24 port switch. Okay, so you can connect 24 devices and have them all connect to each other on that same switch. This generic switch, this is a 4-port switch. So if we have more than 4 devices, we're not going to want that switch. So we're just going to go with a 24-port switch. We're going to click it here. And if you're curious to see what it looks like, we'll click on it. This is what it looks like. Okay, go zoom out. It'll look something like this. You can zoom in and see that all of these ports here connect to different devices. Okay. And on the switch, we can configure it using VLANs, changing the display name, host name. We can even go into the Cisco command line. Okay. But we're going to keep it basic. Alright, so the trick is we need to connect PC 0 to server 0 using the switch. Okay. So first off, we're going to connect the PC 0 with a copper straight through cable. Okay, so we clicked here, clicked on the PC. Fast Ethernet 0, that's where we connect to the Ethernet. And we're going to click switch 0, first port. And you'll see you've got a green light and a red light. So what the switch is trying to figure out how to communicate with this PC. And the easiest way to do that is assign it to an IP address. Okay, right now it's looking for, I think, for MAC addresses. Okay, so we're gonna configure it with an IP address. So we're gonna do this statically, meaning manually. We could also connect it to DHCP if we had a DHCP server on the network. What a DHCP server does is it will automatically assign IP addresses based off of a scope of existing IP addresses. So you might have a scope of 254 IP addresses. Basically what DHCP would say is like, okay, we've got 254 available IP addresses. Let's pick the first one on the list and give it to this person. Okay, that helps it from having any IP conflicts, which is basically when 2 devices have the same IP address. Static can create IP conflicts if you don't do it in an organized fashion. So we're going to give this an IP address of 192.168.1.100. Okay, it's the 100th device on the network. Okay, we could make it 1.2 if we want. We don't want a 1.1 because that's what our router is going to be. Okay, so how we know this is a private IP address is the 192.168. Okay, it's specified as a Class C IP address. It's private, meaning that it's for a private network, which means that I might have the same IP address on my private network as you do as your private network. That doesn't mean an IP conflict because they're on 2 separate private networks. Okay, if it's a public IP address, it means it's public facing, meaning you can see it on the internet. So by default, we've got our subnet mask is 255.255.255.0. It's a Class C subnet mask. Okay. So we close this. This is the PC, if you wanted to look. Alright, so you can see we've got 2 green lights. The switch has figured out who the PC is. It's figured out the IP address. Now, just for visual reasons, because I'm a visual person, we're going to change the display name to that. Okay. Now, we are going to connect the server to the switch. So same thing, we're going to go down here to connections, copper straight through, connect the server to fast Ethernet, drag it to switch, port 2. And again, no red light. So we need to change the IP address. We're going to do 192.168.1.254, meaning it's the last device on the network. Alrighty, so we got our subnet mask. and then save. It did. It looks like it's just learning it. Okay, yep, there we go. It was just taking a little bit of time. All right, so we're gonna name this 192.168.1.254. So now this switch is bridging the gap in between PC and server. So if I hover over PC, you can see our fastest internet's up with that IP address, 192.168.1.100, and our server is up with 192.168.1.254. So that switch is bridging the gap. So now this PC will be able to send a packet to the switch. The switch will give it to the server. And let's test that. So we're going to go here to command prompt, and we're going to send a ping to the server. Ping is similar to sonar, where you send a message out only to track how far, or how long, or how fast the message comes back. Okay, so we're going to send 4 packets from the PC to the server and see if they come back and how fast it comes back. So we're going to go to ping 192.168.1.254. Okay, we're pinging the server. Press enter, and we sent 4 packets. We got a reply with everything in there. Okay, it took about a minimum of 0 milliseconds, a maximum of 1 milliseconds. So it was a very fast connection. So therefore we can talk to each other, and we can do the same thing with the server. Desktop, command prompt, ping 192.168.1.100. And we're pinging it, and we can talk to it. So it's alive. Okay, so now we've got our basic network. Now we can add a couple more devices. So if we wanted to make this PC be able to go to the internet, we can go to network devices, and we're going to put in a wireless device. And we're going to put in a wireless router, WRT300N. That's just a generic Linksys router. This is something you could buy at a store. And it's just kind of there. We're going to add the internet. The internet is the largest WAN, so we want to emulate that WAN. Doing a generic cloud. I'm just going to call it the internet. Okay, so let's connect the router to the internet by going to connections, and we're going to automatically choose connection type to connect the router to the internet. So you can see perfect connection. It comes in just fine. Okay, so we've got a switch and a router. Now we actually don't have to connect the switch to the router if we don't want to, if these had wireless network interface cards. Because this is a wireless router and we set this up, it could have wireless connections, so we wouldn't have to wire it, but we're going to wire it anyway. So we're going to do copper straight through cable, wireless router to switch, port 3, and we're going to configure the router. So this is what the router would look like. Okay, so we got the antenna for the wireless connections. And we've got 5 ports here. One blue section, this is the WAN port. This is connected to the internet, this part. Okay? Or it might be connected to your modem if you don't have a modem built in. These are 4 switch ports, so this port is connected to our switch. And we could connect any of our devices to any of these ports if we want to. Okay. And we've also got a graphical user interface. So this is a wireless N router. And if we wanted to, we can change the IP address. So we're going to change it to 192.168.1.1. And we could set up the wireless if we wanted to. We could set the wireless N only. We could change up the SSID. You can change the security and the access restrictions. Anything we really want to do. Okay. So we're going to change the IP address to 192.168.1.1. And now it's all connected. So this PC should be able to connect to the switch, which connects to the router, which connects to the internet. So if we had internet access set up, this PC could go to any website on the internet by sending requests to the switch, which sends to the router, and the router goes from there. Okay, so this is just our basic network. Now what we're going to do is we're going to set up a private website on our network, okay? And we want it to be private because we only on our network want to view it. We don't want people on the internet to view it. So we're going to go to server. And if you've ever used a server before, you'll know a server has lots of different services, okay? It can be an HTTP server, it can be a DHCP server, it can be a DNS server, it could be an email server, it could be an FTP server, it can deal with the Internet of Things, it could be, it can manage virtual machines. So we're going to set this up as a web server, okay? So HTTP, okay, is for web servers. HTTP communicates through port 80 on the TCP/IP model. HTTPS communicates through port 443 on the TCP/IP model. So these are all on, and we've already got some web pages already set up. Okay, these are hosted on the server. We just got to figure out how to get the PC to go to that website. Okay, so if you know any HTML, you'll notice that we've got a website called index.html. Through HTML rules, usually index is the home page. So we're going to go ahead and edit that page. And we're going to change this up a little bit. Instead of Cisco Packet Tracer, we're going to call it Super Yahoo. And then we're going to change Welcome to Cisco Packet Tracer to Super Yahoo. Get rid of the period, exclamation point. And then we're going to save it. Okay, so we're going to call this superyahoo.com. Alright, so I'm going to show you how this works. So, PC, you're on your PC, you're sitting down. You go into your internet browser. Okay, and you know that the IP address is 192.168.1.254. So we're going to press go. And this browser will send a request, an HTTP request. The client sends a request to the server saying, I want to view index.html. I want to view the website through this IP address. And then it replies with the information. The browser works on the application layer of the OSI model. So we've got this here, so we can click on the links if we want. All right. But I said I wanted to go to superyahoo.com. Why am I putting the IP address? Okay. So let's go back here. So I want to go to superyahoo.com. Okay, it says hostname unresolved. What that means is web browser looks at this and says, what the heck is superyahoo.com? I don't know what you mean. Okay. First of all, there's a bunch of letters, and I only understand IP addresses. This is not my job. This is someone else's job, the DNS server's job. So, let's configure this server as a DNS server. We're going to turn the DNS service on, okay? And DNS, okay, is domain name service, okay? It translates IP addresses into domain names, and vice versa. Translates domain names to IP addresses. So when your internet browser, when you type in google.com, the internet browser just sends it to its DNS, because it's like, what did you just type in? It's the DNS's job to say, okay, google.com translates into this IP address. Okay, so we're going to do the same thing here. This is the DNS's job. It's got one job here. It's going to say that superyahoo.com is bound to 192.168. Oops. Can't type today. That 1.254 with an A record. Okay, so we've got one entry. So, when we update the DNS information on the PC, whenever you type in superyahoo.com, it's going to come out to being this IP address. That's why, so you don't have to memorize all these IP addresses. Names are so much easier. Okay. And you can, oops. All right. So we're going to go to PC, desktop, web browser. Okay. I should be able to get to superyahoo.com now. Nope. Host name unresolved. That's because we didn't update some information. Okay. First of all, on this PC, we never put in the gateway. Okay. Now, if you remember, the gateway is the first router on the network. Okay. So, whenever you want to connect to the internet, this router is responsible for connecting directly to the internet. So this is the gateway. So we need to set up our PC with the gateway, 192.168.1.1, because that's our router. Okay, our DNS server is the one we just set up, 192.168.1.254. Alright. So our IP configuration, if we look at this, the IP address of this computer is 192.168.1.100. That's the private IP address. Okay? The subnet mask is 255.255.255.0. The default gateway is the router, the first router on the network. And the DNS server is 192.168.1.254, because that's on our server. Okay. One thing that I had forgotten to mention, we're going to go back to DNS. Alright, so you can see that we put in a 192.168.1.254. The reason why we did this was because we wanted to keep it a private website. If we want to make it a public-facing website, say for example we want it on the internet, we need to go buy or purchase a public IP address. Okay, and that public IP address will coordinate with the domain name that we need to register from a DNS service. We can't just say, oh, this is superyahoo.com and I bought a private IP. No, you have to actually purchase that domain, the rights to that name. And I don't know if that's already taken. So normally we would put in a public IP, but because this is on our private network, it doesn't really matter what the site is because no one outside of the network is able to access it. Okay. So on the server, let's go ahead and change this information too, so the way we're consistent. 192.168.1.254. Okay. I don't think I have to change this up. Nope, we're good. All right, so let's try it. Web browser, superyahoo.com. Bam, there we go. So when we typed in superyahoo.com, our web browser says, okay, what does this say? Superyahoo.com. The web browser looks at the DNS and say, hey, I've got this text, superyahoo.com. Where do I put it? And they say, okay, 192.168.1.254. We could also do this. .192.168.1.254, and it'll still work. And you could do that as well on public-facing websites. If you wanted to Google, if you looked up their public IP address and you typed in their public IP address, you'd give the DNS a break because it would take it right to there. So, if you're ever typing something, like a website, and it says DNS error, now you know that there's a problem with the DNS server, and that's why it can't resolve that domain name. Or it could be because you typed it wrong, because there's no such thing as that name. So, just to sum up, okay, we have our private network here. All right, we've got a PC, a server, a switch, a wireless router, 192.168.1.1 on the internet. So hopefully, looking at this, you can kind of understand how this network works. And this PC, if we had an internet subscription here, this PC could go on this web browser and type in something in the URL and it would come up. So now what you should do is go in Cisco Packet Tracer, try to create this network, okay? And feel free to experiment with all the different devices and see how big your network and how efficient your network can be. Thank you for watching this video. I hope that you've learned how to create a network in Cisco Packet Tracer.